All right, I'm hoping that you have some idea of what factorization means from year 9, but there's no guarantee of that, so I'm going to teach it from scratch. Everything that we have done so far since your test has been expanding brackets. Do you agree with that?
Yes.
Have we just been expanding brackets and getting rid of them? So what does expanding do? It removes brackets from an expression. Now a skill you need, because you're in year 10 and next year you could potentially be doing low, medium and high maths. I need to give you this skill of factorization, which you'd mainly be using for the higher levels of maths. What is expansion? What is factorization? It's basically the reverse of expansion. If expansion is taking brackets away, factorization is putting the brackets back. It's going backwards. So the first method of factorization I'm going to show you is called common factors factorization. Can I remind you what a factor is? It's any number you multiply to get a certain product. Can someone tell me what the factors of 8 are? What numbers can I multiply together to get 8 exactly? Yes? 1. Let's give someone else a shot. You have your hand up. What else can I multiply? 4 and 2. That's it. Because any other numbers, it's not going to be exactly 8. The first form of factorization I'm showing you today on these two boards is common factors, which is the reverse of distributive law. So what I've taught you so far, since the test, was distributive law, FOIL. What was the next one? That was the two shortcuts. Can someone tell me what the name is of the two shortcuts that we did last? Yes? Yes? And the other shortcut? Good. So literally, all I'm teaching you now and on Friday is backwards of those things. So distributive law looked like this. A bracket B plus C is equal to AB plus AC. Common factors is just, I switch them around. If I've got AB plus AC, I can chuck the A in front of the brackets and have B plus C in the brackets. I'll give you some time to just get that info down, this blue stuff, and then I'll do some examples. Then I need to stop the video. I'll do 3 separate videos today. So you've already done distributive law. This first bit I'm showing you is the reverse of distributive law. Chucking the brackets back. Now some teachers might just give you this rule and expect you to apply it, but I like to step it through. In practice, the steps for common factors factorization are this. What I suggest you is 1, break the terms down into factors. So if my expression was this 2x plus 2, what is the sign that's between 2 and x? Times. So I'll write 2 times by x. And is there a way that I could write 2, the number 2, in terms of factors? What could I times 2 by to get 2? Yes? 1. So I've broken this down to 2 times by 1. So I've broken it down into factors. Step 2, put the highest common factor on the left outside of a set of brackets. So I've broken this down. What's the biggest chunk that you see is common to this and this? What's in both? 2. So what do? I put that 2 at the front of a set of brackets. It's empty right now. And then step 3, put the remaining factors inside the brackets. So I put the 2 on the outside. And so I cross out the 2 because I've removed that. What's left over in my expression? X plus. What's left over in that expression after I've crossed out? X plus 1. So the remaining factors go inside the brackets. X plus 1 there. Those are my suggested steps for it. Step 1, break it down into factors. Put the highest common factor on the left outside. Put anything left over inside the brackets. Okay? Let's do an example. Let's break this down. What's the sign between 6 and x squared? We don't write times. So if I break this down, 6 times What am I multiplying together to get x squared? Good. So that's, I've broken that down a little bit, and then this is 4 dot x. What's the only thing common in those two terms yet? X. But you're Ignite. You're not smooth break. We can break this down further. Are there any factors of 6 and 4 that are the same, yes? Good, so let's write this. Let's break it down even further. 3.2.x.x plus 2.2.x. I've broken it down into the smallest little chunks I can. What's the biggest thing that's common to both of these terms? 2 and something. Can you see that there's, in both of these terms, there's a 2 and an x next to each other, and then another 2 in the x? So what did we do? We broke the terms down into factors. That's what all the dots are about. Step 2, put the highest common factor on the left outside of a set of brackets. What did we identify the biggest chunk is? 2x. Empty brackets. So what goes into the brackets? Whatever's left over, 3x add 2. That's factorization. Okay? If you ever want to check that that's correct, expand it again. What's 2x times by 3x? 6x squared. What's 2x times by 2? 4x. This example is a little more complicated. You're probably looking at that and going, what the hell? That looks nothing like what you've been showing me. What is the sign between the 4 and the brackets? It's a multiplication. Plus, what's the sign between the little butt cheeks of the brackets? What do we, it's multiplication again. A plus 2 dot A plus 1. Is there a chunk that is common in both of these terms? What's the biggest thing that's common in both of them? See, A plus 1 is in both. What do we do with a common thing? It goes out the left. A plus 1 goes out on the left of a set of brackets. But there's some stuff left over. If I've removed A plus 1, what's left over? Negative 4. And what's this? Plus A plus 2. Is there stuff that I can do in this set of brackets? If I've got negative 4 and positive 2, what do I have?
Negative 2.
All done. So I've got A plus 1, negative 2 plus A. That's a slightly more complicated factorization. Huh? The problem with you looking at that is, I agree that you don't see what the application of this is until you start doing maths next year, okay? And you're only going to see the application of this if you do the harder level of maths. The only students that I've ever had that actually see the point of this is the ones that skipped. So I had a couple of year 8 kids do year 9 and year 10 in a semester because they wanted to skip. And they're like, oh, that's why you teach us in year 8 that's why you teach us in year 9 that, because they saw it all in one go. You don't get to see that in one go, you're not skipping over, right? Last one here. This is the most complex factorization you'll have to do. None of this looks similar, but yeah, it is. If I'm squaring something, what does that mean? I'm timesing it by itself. So that first term is x take 5 times by x take 5. And the second term is 2x take 5, negative 2x take 5. What's common across both of those? What's the same in the x take what? X take 5. That goes on the left. Have an empty set of brackets. What's left over? If I take an x take 5 and x take 5, what's left over in this situation? X take 5, take 2. Is there something I can do with the 5 and the 2? If I've got negative 5 and I take it further to negative 7. That's common factors. Question?
Why couldn't you just take the there's 3 of them? You can take 2 of them.
Sorry?
There's 3x, take 5.
Yeah, but the problem is I can only ever divide one thing by its same thing, okay? I would have to have another x take 5 to divide this out. It won't disappear. Okay? Alright, I'll stop the video there.